Welcome to today's session on correlation. Today we'll test correlation with the help of SPSS. So I will combine both theory and practice all together for your better understanding. As we know, correlation is an association between variables. So we always prefer Pearson correlation and Pearson correlation which the values lies between -1 to 1. Anyway, so before doing that, I will tell you that if value comes uh, in plus more than 0, then it is a positive correlation. If value comes in minus, it is a negative correlation. And if value is 0, then here is no correlation. So to do the test, we should have a hypothesis that I will tell you after some times. So we need to follow two-tailed test, that is error appears in both the sides and data will be normally distributed. Then confidence interval. So our confidence interval is 95%. Then significance, with 95% confidence interval, our significance or p-value is 0.05. So I want to tell one thing: if significant level is more than 0.05, then data is insignificant. But if p-value or significance level is equal or less than 0.05, then data is significant. That means there is a significant correlation. Then another important thing, that test. When we will do the test, we have three options, that is vibrate, partial and distance. So partial, when we have control group, then distance, if we are used to see the case wise or pair wise distribution, but majority times we are not following this partial and distances, and we will prefer vibrate test. So now I'll go to the hypothesis. So my study hypothesis, I prepared income will increase with an increasing age. So income is dependent variable over here and age is independent variable. So when we have hypothesis, then there automatically null hypothesis will appear, and null hypothesis will deny our study hypothesis. So what null hypothesis saying over here? Null hypothesis saying that income won't increase with an increasing age. So let's begin today's test. I have prepared a data set having both the variables, that is age and income. So I am clicking over here and my data set open. So here you can see I have age variable, then income variable, and data I have 30 respondents information. As for your knowledge, I want to tell you that when you will do the test, you should have minimum 30 samples as per statistical rules. Okay, so our hypothesis was that income will increase with an increasing age. That means when age will increase, income will also increase. So income is depending upon age, isn't it? Okay, now do the let's do the test. So we have on top, we have few options: file, edit, view, data, transform, analyze, and direct marketing, graphs, utilities, add-ons, windows, hub. So we'll go to analyze option, we'll click analyze, then we'll go to correlate. See, correlate is there, means correlation. searching for association, searching for linear relationship. So when you will go to correlate, you will have vibrate correlation. So click vibrate, because this is our area of interest, isn't it? So I'm clicking over here. So when I click, I will see a dialog box appear. So here I have to select variables. So my variables is that age and income. So age of the respondent, that is the raw age of the respondents, and then income of the respondent. So I am selecting income also. So you see options, means and standard, we are not interested for this time. Exclude cases pairwise, not interested. Okay, continue. Then you just see bootstrap. In bootstrap you can see level, confidence interval, as I mentioned, no, 95%. So by default it is uh, here 95%. So no need to touch over here. I'll just click continue. Then I mentioned that we are following Pearson correlation, isn't it? So you see it has already been checked. If it is not checked, then please check Pearson. Then another thing I mentioned that we are interested for two tail, because we assume that our data lies between normal distribution and error appears in both the side, both the angles. So see, two tail test. One tail mean error appears in one side and data may not be normally distributed, but here in social science we generally assume that our data is normally distributed. So that's why two tail test, it has been already checked. If it is not checked, please check. Then flag significant correlation. So I'm just checking by which will get the significant value, that either it comes under 0.05. If it is 0.05 or less, then it is our correlation is significant. And then we have to see the value also. So that I will tell you, but for now we'll do the test. So we have two options, important options over here. One is okay, one is paste. So I always prefer paste option, because in paste option you will get the process, and later on you can use the process if you save paste paste option, isn't it? So I will click to paste option now. I'm clicking. Yes, dialog box appeared as soon I clicked. So pairwise. So for time being, I'll just save this one. I am saving this. So I'm going to save in desktop. So it will appear as syntax, isn't it? This test. So syntax, I'll write correlation test, and it is there in desktop. So I will save here, and save as type syntax, because it is our test file, our statistical testing file, isn't it? So I'm saving over here. Save. It has saved. So I'll close everything and close my data set. Yes, yes, no, no. Okay, then I saved correlation test. So I have to search. Okay, it is here. So I'm clicking again to reopen the test. It is taking bit time. Okay, it is opening now. Software is bit big, and that's why it is to take time. Anyway, so it has opened now. You can see. Then here data is not linked. Correlation data is not linked, so we have to link the data. So I will go to file, then open data. So data is saved in desktop, that is SAB. Data file is always SAB, so I named it test1.sab. So I am clicking here and I'll open it. So you can see that our data is already uh, linked. Now data is linked, so I will go pair after pairwise, then I'll click and we'll get the test result. So here you can see the test result. Anyway, I will just tell you. So this is the test result, and in this result our question was age and income. So you see age of the respondent and income of the respondent, and the value, Pearson correlation value is 0.763. Then income and age is also same, and significant they mentioned that 000, which is less than 0.05. That means it is significant. So significant relationship is here. That means when age will increase, income will also increase, isn't it? So income is depending on age. So correlation is significant at the 0.01 because it is less than 0.5, even it is less than 0.01 also, and that's why. And two-tail test, so they are showing us what happened to our test. Now I want to tell you one important thing is that uh, see positive correlation. So if value is plus, then it's a positive correlationship. And you just see our this value is also plus, that means it is positive correlation. And significant means it is under 0.05. I want to show you again. If significant level is equal or less than 0.5, that is 000, 0.000 or 0.05, whatever value, no, within that means data is significant, or in other words you can say data is correlated with each other. So in our test I found that data is correlated, it is less than 0.05. So these two values are very important, and then you can copy this and paste to Word. This is all about correlation test, and you need to understand Pearson correlation value and the level of significance, that if it is more than 0.05, then what will happen. So our hypothesis proved here that when age will increase, income will also increase, and we rejected the null hypothesis. So our study hypothesis has been proved, and then you copy it and paste to Word file. And thank you for watching. Have a nice day.